Hello everybody, this video clip is this video clip number 6 for our chapter 3 of the course Calculus for Business 2. Okay, previously on your Calculus 1, if you are finding, if you can find at first the first derivative f prime, you can look at your f prime x as another function of x, so you can find further derivative with respect to x. Okay, so to have your second derivative, your third derivative, or the fourth derivative. And we also have another kind of notation in terms of fractions, dy by dx, d2y by dx squared, d3y by dx cubed, or d4y by dx fourth. Okay, however, in this course, at the beginning we already have f of x y, and then you can find f sub x and f sub y. So this f sub x can be regarded as a function of x and y. So in terms of function of x and y, you can find another derivative with respect to x and another derivative with respect to y. This one as well, in terms of function of x and y, you can find further derivative with respect to x or further derivative with respect to y. So it means that the second partial derivative of a function of two variables, you can have up to 4 of them. Okay, so let's look at this one, which is the higher order partial derivatives of the given function. So again, as we told you that the our function z, it is in terms of f of x, y. The first order derivative, it is dz by dx or dz by dy. But if you find further derivative with respect to x, so you are going to write the operator. So this one is the operator in front of the one that you did previously. Okay, so this one is the one that you did before, and then this is the one that you do follow, okay, in front of it. So you have dz by dx and operate by dz, d by dx again. So it means that you have two of the curve. That's why you got d2 here, and then you got dx twice, so that's why you have dx squared there. Okay, and this one is not that confusing, because if you talk about your notation using the subscript, you are going to do a subscript at the end, behind your function. So it means that you got f sub xx. Okay, this one as well, this is not that confusing, because first you are finding a derivative with respect to y, and then second you follow by another derivative with respect to y as well. So you see that you got two of the d, so you got d2z, and you have dy and dy together, so you have your dy squared, or your f sub y, because you just do it this way, right, to write down another further derivative at the end of your function. Okay, however, if you do something in different variable, so for example, at the beginning you do dz by dx first, so here's the one that you do first, followed by d by dy. Okay, don't forget that if you use the fraction notation, the operator that you do, following, you need to put it in front of it. So it means that what you calculate the order is from your inside to outside. Okay, however, if you use the subscript notation, you're going to put the following derivative at the end of your function. So this one, it is f of xy. So it means that the order of doing derivative, of finding derivative, it is from your left to your right. Okay, from in to out, something like that. So this one as well. Okay, so this means that you find dz by dy first, followed by d by dx. So it means that it will come out like this. Okay, from the one inside to the one out there. Okay, this is the order. But if you using the subscript notation, you are going to put the one follow at the end of your function, right? So it is you f of yx, so it means that you do y first and then go out for x. Okay. So let's take a look at this one. Of course, if you need to find all four second partial derivative, okay, you need to first, of course, finding your first derivative first. So let us use this notation. So your f sub x, okay, derivative go directly to your x cubed. So you have 3x squared and y squared, keep it. And the derivative for the second term go directly to x squared, which is 2x, and y to the fourth, okay. And f sub y, a derivative with respect to y, okay. Then right now a derivative go directly to your y squared, so you have 2y, and then you got x cubed stand still. And for the second term, it is go directly to your y fourth, so you have 4y cubed, and x squared just stands still like that. Okay, so let us do further derivative with respect to x. Okay, so it is f sub x and then sub x again, or it is a derivative with respect to x of this term, isn't it? Okay, because you just finding the derivative with respect to x first. So with further x, so you got 6x, y squared just stands still. You got a 2 and y fourth just right there. Okay, and if you find f sub x followed by f sub y, or this is the notation, so you can use this one as a notation, 3x squared y squared and 2xy fourth. Okay, so here your 3x squared has nothing to do, a derivative go to y squared, so you have 2y, and your 2x, okay, just stand still, derivative go to y to the fourth, so you have 4y cubed, okay, or you can simplify it a bit to be 6x squared y and 8xy cubed. Okay, on the other hand, if you finding f sub y and then followed by the x, okay, so it means that you find a derivative, this one is a what, f sub yx, okay, so it's a further derivative of this one with respect to x, so just copy it first. Okay, so here the one with respect to x, so you have 3x squared, right? With the 2 here, so you have used 6x squared y. This one you have 2x with the 4, so you have 8xy cubed. Okay, and if you need to find f sub y, or the further derivative with respect to y of that f sub y, here you're going to have 2x cubed, okay, derivative of y with respect to y is 1, and this one you got derivative of y cubed, which is 3y squared, or you can simplify it to be 12x squared y squared. Okay, can you notice something here and there? Your f sub yx or f sub xy usually, okay, 99%, okay, they'll be the same. Okay, 99% they'll be the same. However, even though they are the same, but if we ask you to do either this one or that one, you need to do it in the right order. Okay, you need to do it in the right order. For example, this one you do the x first, followed by the y. This one you need to do the y first, followed by the x. You cannot switch the order. Okay. Again, here is the typing version of that problem. How about this one? If you need to find a derivative, I mean the third order derivative, okay, with respect to, you know, x, y, z. So if we write this way, which one that we do first? So here we do the z first, and then followed by the x, and followed by the y, and followed by the x. Okay, so first dw by dz, it is a what? So you just use the chain rule, right, to kick down the 3. So you have this one, and then a derivative of the inside with respect to z. So the first term becomes 0, the second term also 0, the first term is 4. Okay, so next, if you need to find the second derivative with respect to y and z, so it means that you do this one followed by you do this one first, followed by d by dy. Okay, so it is d by dy of sorry, this one, the chain rule, you still have a 2, so here's 12 of 2x 3y 4z raised to power 2. Okay, so you are going to use the chain rule again, so to have 24 and 2x 3y 4z, right now it is a power 1, and a derivative of the inside with respect to y alone. So the first term has no y, the second term has 3y, and the last term has no y again, so you have this. And last operator, you need to operate with the d by dx, okay, of the one that you just did previously. So you have a derivative with respect to x of 72 and 2x 3y and 4z. Okay, so here is 72, and the derivative go directly to your x, so you got 2 and the rest are 0, or you end up with 144 as a result. Okay, so here is the typing version of that problem, but just don't forget that this one you need a parenthesis as well. Okay, the parenthesis is missing most of the calculation, right? How about this one? If you are, starting with the implicit relation like this, and you need to find a derivative, a second derivative of z with respect to x twice. Okay, so what you do is to take a derivative with respect to x both sides, right? So here you got 2z, and then because your z has the x hidden, so you have dz by dx. This one you got 2x, this one it is another variable, but right now derivative with respect to x, so you have 0. So it means that dz by dx, okay, as what we did previously, it is x over z. If you need to take further derivative with respect to x, so it is the first derivative with respect to x followed by another derivative with respect to x. So you just pull the one that you did before. This is x over z, right? Just write down. Again, here your x is hidden, is it? So this means that if you need to calculate this one, you need to use the quotient rule. Okay, you need to use the quotient rule. So this one actually is look like you taking another derivative with respect to x both sides of your equation. Okay, at this point, okay, you do the taking the derivative with respect to x both sides of your relation there. So you got the bottom derivative of the top minus the top derivative of the bottom over the bottom square. Okay, so this one you dx by dx, it is simply a 1. But what is your dz by dx? You already have it, right? Which is your x over z, and then this one is z square. So you can simplify, for example, this one multiply, so you have z square minus x square, and then the total divided by z cube. Okay, so this one is how you evaluate further derivative, higher derivative from the implicit defined function. Of course, you are going to have several examples to do. You got 4 exercises okay, for you to do. So please do it, okay, please do it, and then we are going to see you again on the next video clip. Bye bye.